Today I am going to discuss with you 4 to 5 questions. Let's solve them one by one. Okay, let's start. See this first question. Here there are two nodes given P and Q, across which we have to find out the equivalent capacitance across these nodes. Okay, there are 5 capacitors which have the value C microfarad. How to find this? There is one approach to solve this type of question. First, you should do one thing: name all the nodes. Here, 2 nodes are already named, so there are other 2 nodes are this and this. So name this node as R and name this node as S. Okay, so name this as R and this as S. So now, how to solve this? Put those 2 nodes P and Q here, P here, Q here, and there are 2 more nodes here, R and S. R and S. Put them here, R and S. R, S. Now, between P and R, there is one capacitance. See. Now, between R and S, there is one capacitance. So R and S, between them one capacitance is there. Now, between S and Q, there is one capacitance. Between S and Q, there is one capacitance. Now this capacitor, actually these are actually capacitor. This capacitor is between P and S. This capacitor is between P and S with the value of capacitance C, and between R and Q, there is one capacitor with capacitance C. So this is C, this is C, this is C, all actually in microfarad, and we have to find out the equivalent capacitance between these two terminals, P and Q, P terminal and Q terminal. And I think you know what kind of bridge is this. This is one Wheatstone bridge. Whenever we apply a voltage across this, there will be no current flowing through this branch. Why? Because these opposite branches, the multiplication of these opposite branches are same. The capacitor's value of this opposite branch is actually, if we consider one resistive network, P, Q, R, S. Okay, across it if we apply, and if here something like X, and if we apply some voltage source across this, then if PQ is equal to RS, then if current flowing through this resistance X is I, then I will be equal to 0. Okay, are you getting my point? Then I will be equal to 0 if P multiplied by Q is equal to R multiplied by S. That's why through this branch, if any voltage source is connected across these 2 nodes, then no current will flow through this branch. So we can neglect this branch. Okay, this branch can be neglected. So what will be the new circuit? The new circuit will be looking like this. See here, and here C, and here C, and this is P, this is Q, this is R, this is S. Okay, nothing will be flowing through this, so we can eliminate that branch actually. So what is going to be equivalent capacitance? So C eq is going to be what? Look, this capacitor and this capacitor with capacitance value of C are in series. So here we will get equivalent as these both are in series, so this will be C by 2. These both capacitors are in series, so C by 2. And after this we can draw this like this way. P and Q, okay, and this is C by 2 and C by 2, and capacitors in parallel adds up, so C eq equal to C by 2 plus C by 2 equal to C. So in the last question the answer was C eq is equal to C by 2 plus C by 2, which will give the result as C. So the equivalent capacitance of that circuit was C microfarad. Okay, move to this next question. Here this question is even simple, easier. Okay, now how to solve this question? Follow the same procedure. Actually, look, these two nodes are actually here named as P and Q, and we have to find out the equivalent capacitance across P and Q. Look, this P node, this is actually shorted, so there are no resistance or capacitance across this, so this P node goes here, and this is also P node actually, because these 2 points are equipotential point, so this is also P node, and here it is shorted here. Okay, so this node is also shorted, so this point and this point are equipotential points, so this is Q point. So now follow the same procedure. Now give two nodes P and Q, P here and Q here, and between P and Q there is one. Look at this circuit, P and Q. Between P and Q there is one capacitor of capacitance 2 microfarad. Okay, 2 microfarad, and between P and Q there is another capacitor. Okay, actually C, 2 microfarad, and between this there is one capacitor of 2 microfarad. Okay, so this is P terminal, this is Q terminal. Okay, this is P and this is Q. So what is the equivalent capacitance? C eq is equal to, so here 2 by 3 microfarad. Why? Because 3 capacitors are in parallel, so C eq is the capacitance value divided by 3. If there were capacitors of value C in number of connected like this, they were in parallel, so across this the equivalent capacitance would be CQ is equal to C by, if there are n number of capacitors in parallel, then the equivalent capacitance would be C by n. Okay, that's why here 3 capacitors of equal values are in parallel, so that's why the C equivalent is 2 by 3. Now move on to the third question. This question is actually of symmetry. Okay, now how to solve this question? Look, this circuit is actually symmetric. If you vertically cut this circuit, you will find out that in this portion the resistance, this portion is reflection of this portion. Okay, if you fold this page across this line, then you will find that this and this portion will superimpose. Okay, so these are actually symmetric figure. This is actually symmetric figure. So that's why this circuit is actually symmetric circuit. All the resistance values are equal, so this is actually symmetric circuit. So how to solve this? Solve this question like this. If the current entering through this node is I, and after entering through this node, the current will leave the node through these branches. Okay, so let the current flowing through this branch is I1. So what current will be flowing through this branch? Through this branch, the current flowing will be I minus I1, because I1 is flowing through this. So I minus I1 is flowing through this in this direction. So I minus I1 will be flowing through this direction. Now as the circuit is symmetric, so the current entering into this node, this B node, okay, the current entering into this B node will be from this branch, it will be I1, because this is symmetric. As from the node A, the current leaving this node and entering in this branch is I1. So the current leaving this branch will be I1, which will be entering this node B. Okay, why? Because the circuit is symmetric. So the amount of current leaving here will be the amount of current entering here, and from here the current entering will be I minus I1. So both added up, what will be the current? I minus I1 from this plus I1. I1 will cancel out, that will give I. So output current is I, input current is I, output current I. So this circuit actually obeys KCL. Okay, Kirchhoff's current law. What is Kirchhoff's current law? Actually KCL is actually all about conservation of charge. Conservation of charge. Okay, so if current leaving this node is I1 and current entering this node is I1, so here I1 is flowing through this branch, here I1 is flowing. So if I1, in this portion the current was I1, and in this portion also current is I1, so no current has entered in these branches, neither in this branch nor in this branch, or no current has entered, has come from this branch to these branches. Okay, so this no current has gone into these two branches, or no current has come into these branches. Okay, why? Because if any current would have come here, I2, say I2, then the current will not be same. The current flowing through this branch and flowing through this branch are same. That means no current has either entered or have left this from this node. Okay, from this node either any current has entered into these branches, or from these branches no current has entered into this branch from this node. Okay, so we can eliminate this node. Okay, so whatever current might have come here, okay, after I minus I1, the current was here I minus I1. So if I2 current was flowing through this branch, so that I2 has come and that has gone like this. Okay, no current has entered in this node. So we can eliminate this node and open this. Actually open, and from here we can say this is not connected. If no current is flowing through this, we can say this was no current, not connected. We can imagine like that. So after removing this portion from here, we get this type of circuit. Okay, now what is the equivalent resistance across A and B? Look, these and these are in series. Okay, these and these are in series. So R plus R, what will be that? 2R. Okay, now this 2R is parallel with R. Now 2R into R divided by R plus 2R. What will be the value? 2R divided by 2R square divided by 3R, equal to 2 by 3R. Now the circuit now looks like this. R, here R, okay, R, here it is R, and now here it is 2 by 3 R, from here R. Okay, so what is going to be, now these are in series, so this will give 2R, these are 2R, 2R, R plus R, 2R, 2R plus 2R plus 2 by 3R is equal to 6 and 8, 8 by 3R, and this is 2R. So it's like this, 8 by 3R, okay, y2, and here 2R in parallel, B and A. Now what's going to be the value? These are in parallel, so RAB is equal to 8 by 3 into R into 2R divided by 8 by 3R plus 2R. What's going to be the value? The answer will come 8 by 7R, RAB. This is the equivalent resistance. Okay, this is the last question, so let's start. Now look, there is one resistance R, thereafter there is one resistance in series, thereafter in parallel, thereafter 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 in series, thereafter in parallel. So this goes on for infinity. This is an infinite ladder circuit. This is an infinite ladder circuit. Okay, so how to solve this type of circuit? Many times you have solved some mathematics like this: root over x plus root over x plus root over x plus root over x equal to something, and solve for x. It's almost like that. Okay, now how to solve? Actually, this is infinite circuit. Okay, if we eliminate any of its branches, okay, if we eliminate any of its branches, will it actually impact in the equivalent resistance value if we if we eliminate this branch? Okay, let's eliminate this branch and take from here. If it's not here, okay, if it's not here, then also the circuit looks like same, because there are infinite number of elements. Okay, resistive elements, there are infinite number of resistive elements. If we eliminate this branch, that will not actually impact very much. Okay, there are infinite number of branches, so eliminate this and think that after eliminating this, if this circuit does not exist, this element, so consider from here the circuit to infinite number of elements. Take this as Req from here. Okay, so what now the circuit looks like? Now imagine how it looks like. Now the R equivalent, this is like this. This circuit, draw R, this is R. Now it is R equivalent, so we can replace all this circuitry by R. Okay, Req, because we have taken it as Req. So now the circuit has actually simplified. Now it's very easy to calculate the R equivalent. What will be the R equivalent? Because this portion are in series, so R plus Req, and this R plus Req is in parallel with R. So R equivalent of total, okay, R equivalent is equal to, what is the value? R multiplied by this plus this, that is R plus Req divided by R. This is R plus this, R plus Req. Now if we calculate, it's going to give Req is equal to, what is the value going to be? R square plus R into Req divided by Req plus 2R. Now Req square, cross multiply this, Req square plus 2r into Req equal to r square plus r into Req. So what's the value? Req square r multiplied by Req minus r square equal to 0. Now solve this. The Req will be, this is a quadratic equation, so solve this like by using the formula श्रीधर आचार्य व्यवहार करो. हाँ, so minus b plus minus root over b square r square minus 4 ab is equal to r divided by 2. That is minus r plus what is going to be, this is going to be actually, sorry, this is plus. Okay, so this is going to be 5 root over 5r divided by 2. So minus 1 plus root 5, okay, by 2 into r. This is going to be the answer. Okay, why I have not taken this minus sign? Because if I take this minus sign, then R equivalent will turn out to be negative, but resistance can't be negative. So I have taken only the positive value. So positive value would be giving this. So R eq is equal to minus 1 plus root over 5 divided by 2. This is the answer. Okay. Thank you very much.